the second assignment on 5-6, page 378. Which one? 65. All right, here's 65. The directions tell us to find an equation of the tangent line to the graph of the function at the given point. So the function is y equals 4x times the arc cosine of x minus 1. And then the point they give us has coordinates 1, 2 pi. All right, so if we're going to find the equation of the tangent line, we need to know the slope of the tangent line. If we need to know the slope of the tangent line, we have to find the derivative. So y prime equals, and then product rule. First function, 4x, times the derivative of the second function. The derivative of the arc cosine of u is negative square root of 1 minus u squared times the derivative of u. Derivative of u outside the parentheses, not under the square root. The derivative of x minus 1 is 1. So that's how I get the first half of the product rule. Plus, then the second function, the arc cosine of x minus 1, times the derivative of the first, and the derivative of 4x is 4. All right, so you guys with me on the first step? Okay. Now, let's simplify that a little bit. So 4x times the negative 1, I can make that negative 4x. And then underneath the square root sign, I don't really have to square that binomial out, okay? But I do realize that if I do, you know, when I square that binomial out, when I square that 1, I'm going to get a 1, and I can combine it with the 1 in the front, and I can make that a little bit simpler. So, oops, that shouldn't be a square there anymore, should it? So square that. Well, you don't have to. I squared the x minus 1, got that, and then distributed that negative sign. Then I was able to combine the positive 1 in the front with the negative 1 in the back and get rid of that. So that's kind of optional whether or not you want to do that, but that's my final version of the derivative. Now, the good news is you don't really have to simplify the derivative, do you? Because you're going to use it to find the slope of the tangent line. Now, it's usually easier to simplify it when it's still in symbols than it is once you plug numbers in. But I can't say that it always is. So, at the point 1, 2 pi, let's put an x, or put a 1 in for x. There isn't a y in our derivative, so we don't put the 2 pi in there anywhere. And then you simplify it. Now, be careful with that arc cosine. So when I make the arc cosine of x minus 1 into the arc cosine of 1 minus 1, that's 0. And then the arc cosine of 0 is pi over 2. Yes? Yeah, if you don't know how to simplify it, you can substitute in. So, everybody able to follow me down to y prime equals negative 4 plus 2 pi? That's our slope. So now I'm doing y minus y1 equals m times x minus x1. So there's your y1. There's your x1. That's your m. Okay? And they don't tell us what version of the equation to give them. So technically, we can be done here. Now, pay attention to your surroundings, right? If this is a multiple choice test, look and see. Are the answers written in that form, Are they written in that form? I mean, obviously, then if they're written in slope-intercept form, you've got more work to do. If it's a free response question, they may specify what version to give the equation in. They may not. They may ask you to do something with it. If the next thing, if that's part A of a free response and part B says draw the graph, well, you're going to want to do that anyway, aren't you? Okay? So you've got, like I say, pay attention to your surroundings at that point. Be able to give the answer in any form it's asked for. Yeah, Alex. Uh-huh. Well, you'd have to substitute that stuff into there. You can't leave the x's in it if it's going to be the slope. Well, I mean, I guess you can, but they won't give you, nobody's going to give you credit. If you just put that right there, nobody's going to call that good. I know I'm not. Okay? Oops. All right, what else? Which one? 91. All right, on 91, let's see what's going on here. All right, angular rate of change. In a free fall experiment, an object is dropped from a height of 256 feet, a camera on the ground 500 feet from the point of impact records the fall of the object. And then they give us that figure. Part A, find the position function giving the height of the object at time t, assuming the object is released at time t equals 0, and at what time will the object reach ground level. So let's get the position function. All right? Would you happen to remember that? That's the general form of either for vertical change, for vertical position. Either something dropped straight down or shot straight up. Okay? So S of t, position with respect to time, equals negative 16t squared plus the initial velocity, t, plus the initial position. Now, that's the one we use when it's in feet and seconds, which is the units they gave us here. Okay? So, and I would suspect that you will be given that on the AP test if they ask it. I'll have to look that up for sure. Okay? As time gets closer, I'll look that up and see if they give you that. But you know how kind of like on the ACT, sometimes they'll give you a formula they expect you to use. AP does the same thing. Because again, their main goal is to test your calculus knowledge, not your do you remember the formula knowledge. Having said that, you'll have to remember all the calculus formulas. Okay? But that's not really a calculus formula. That's why I think they probably would give that to you. But again, I need to check. Okay? So the initial velocity, because they're just dropping it, they're not firing it or shooting it or slinging it or anything else. The initial velocity is 0. They dropped it from a height of 256 feet, so the initial position is 256. So our position function then, S of t equals negative 16t squared plus 256. Then the question was, at what time will the object reach ground level? Well, what's the position of the object when it hits the ground? It's not 256, it's 0. When it hits the ground, its position is 0. So set the position equal to 0 and solve it for t. Okay? And when you get t squared equals 16, we all know that t equals plus or minus 4 seconds. But at negative 4 seconds, they haven't dropped it yet. So that can't be it. Okay? So it's 4 seconds. We good on part A? All right, now the hard part of this one. Find the rates of change of the angle of elevation of the camera when t equals 1 and t equals 2. All right, we'll worry about t equals 1 and t equals 2 in a minute. Find the rate of change of the angle of elevation. Find the rate of change of theta. Okay? Everybody understand that that's what we have to find? We have to find the rate of change of theta. That means we have to find the derivative of theta with respect to time. Okay? Because it's going to be a function of time, isn't it? All right. Now, what I have here first is I'm going to rethink this diagram. There's theta. That's 500. Theta is going to change. As the object drops, theta changes, making a new right triangle every time, right? Not only does theta change, that 256 that they gave us for the height, the object doesn't stay 256 feet off the ground, does it? So not only does the theta change, the h changes. It's this high, then it's this high, then it's this high. Okay? So I wrote an equation involving theta. Tangent equals opposite, which I can't call 256 because the object doesn't stay at 256, over adjacent, which I can call 500 because the camera does not move closer to where the object's going to hit. It stays there. Okay? So if the tangent of theta equals h over 500, we've been working with inverse tangent and inverse sine and inverse cosine, or arc. That means then that the arc tangent of h over 500 equals theta. We have an equation for theta now. Okay? So I'm going to flip this around. I'm going to take that equation, turn it around, because, you know, we like it better that way. We don't like blah, 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 blah equals y. We like y equals blah, blah, blah. So that's what I'm going to do. There's the y, so to speak. So theta equals arctangent of. Now, something over 500. Now, what's the something? I don't want it to be h. Theta's not really, you can say that theta is a function of h, but what's h a function of? Time. It all depends on how much time has passed, right? So I need to rewrite h. So if I do this, let's see. The height of the object that the position of the object we found up here, doesn't that give us the height of the object? Isn't that the way we used it in part A? Okay, we said the position was 0 when it hits the ground. The height is 0 when it hits the ground. So, see how part A leads us to part B? That's a common way to ask an AP question as well. Okay? So, we're going to use what we found in part A. That's the height of the object. So, replace the h with negative 16t squared plus 256. And now, I take the derivative. The derivative of theta. Theta's got to be a function of time. In fact, if you look at this, what's the variable? The only variable in that whole thing is a t. So theta is a function of time. So d theta dt equals. All right, so quotient rule. The bottom, 500, times the derivative of the top. The derivative of negative 16t squared is negative 32t, minus the top, negative 16t squared plus 256, times the derivative of the bottom, 0, over the bottom squared, 500 squared. All right, so, oh, wait. That's the derivative of u. I'm sorry. That's all of that is the derivative u part of the arctangent of u. Sorry. Okay? So it's 1 over 1 plus u squared times the derivative of u. All right? Then you simplify, simplify, simplify. All right, good news here, times 0, so that's gone. Bad news here, I have a fraction in my denominator. That's why I multiply by 500 squared over 500 squared. In front of the parentheses, I can reduce that. So I did. Then next here, those divide out. So let's see, let me follow this. Those divide, no, they don't either. Not yet they don't. Let's do this. Multiply those together, I get 500 squared. When I multiply this times 500 squared times 1 gives me that. Then the 500 squareds divide out. But, and I've almost covered it up, I still got to square that. So I square that and get that. And then the fun just keeps on happening. So let's see, what did I do next? I must have divided this into this. So I now have the negative 4t, negative, and then 4t. Now that's just a 400 because I divided 625 into it. Let's see, that goes there, that goes there. These get combined to give me that. All right, then what did I do? Keep the negative out in front, multiply that times that to get that. Factor out a 16 to get that. Divide that 16 into that. That gets me here. Now I'm good. So that is d theta dt simplified. Now, what did we learn earlier? If you can't simplify it, do what? Plug in a t equals 1 way up here if you have to, wherever we first had it. Okay?
Pardon the interruption, teachers.
All right, so you substitute in 1 for t and then 2 for t because those are the 2 times they ask you. Since the angle's getting smaller as the object drops, does it surprise you that the rate of change is negative? It shouldn't, right? The angle's getting smaller, the angle's decreasing, its derivative should be negative. And then you may struggle with what unit to put on here. We always measure angles in radian in this class, and then so it's radians, and then per second, because second was the time they gave us. So, good problem. Very AP-like. Kind of an easy one for the AP test, to be honest, but very AP-like. Because then they're going to ask you 2 or 3 other things about it, too. Okay? All right, anything else from 378? All right, let's go to the last section. All right, it was section 5.7. We had 2 assignments on 385. So let's go ahead and have questions from either of those 2 assignments on 385. Number 7. All right, on number 7, we're supposed to find the integral. And if you'll recall, this is the section where we said it's impossible to try to work an example of everything. Every technique you can possibly imagine could come up. Number 7 requires a little bit of long division. So I put the 0x in there to hold the place for the x column, and then I've got a mess of zeros here. I got to hold the place for the x squared column and the x column and the constant column. So I just get x, all right? Here's how you do it. X cubed divided by x squared gives you the x. Then you multiply. So then x times 1 is x. Put it in the x column. X times 0 is 0. That's in the x squared column. X times x squared is x cubed. That's in the x cubed column. So then you subtract. 0 minus 0 is 0, so nothing there. 0 minus x is negative x. 0 minus 0, x cubed minus x cubed. So I just get a negative x. So we can rewrite this. X cubed divided by x squared plus 1 is equivalent to x plus the remainder over the divisor, which when I wrote it here, I put a negative, put a minus instead of a plus negative. Because 0 minus x is negative x. All right, once we've got that integral we can do. This integral requires a substitution. So you let u equal x squared plus 1. Du is 2x dx. I don't have a 2, so 1/2 du equals x dx. Rewrite it. Take the integral. Put the x's back in. $15. All right, still finding the integral. All right, on 15, looks like it could possibly be, what, an arc sine or maybe an arc secant, okay? So, you know, and it may take you a little while to figure out what the u needs to be. But right there, in all those formulas for the arc trig functions, there's always a u squared in the bottom somewhere, isn't it? Well, for there to be a u squared, for the x to be something squared, u is going to have to be the square root of x. And let's see how that works out. So if u equals the square root of x, we know that du equals 1 over 2 radical x dx. And look, I've got a 1 over radical x dx. I didn't expect it to work out this way when I started, okay? But I've got the 1 over radical x dx. I just need to get rid of the 2, so multiply both sides by 2. So I really thought I was probably going to have an arc secant problem, but I'm not, because the du is going to take care of that or take care of the square root of x in the front. Okay? So 2 times the integral of 1 stays 1, square root of 1, write it as 1 squared if you want, minus, and then instead of x, if u equals the square root of x, then x would equal u squared. And then, and here's the part that makes this work, the 1 over square root of x dx, all that gets replaced by the 2 du. So, not really the way I thought it was going to play out, but that's the way it plays out. Arc sine instead of arc secant. So now that we've got that fits the arc sine exactly. So that'll be the arc sine of u over a plus c. And then the square root of x over 1, just the square root of x. So 2 times the arc sine of the square root of x plus c. All right, what's next? And what's after that? 19, somebody said, then 35. All right, 19, is this just a find the integral? All right, find the integral. All right, now, the way this is written, that's looking a lot like a u squared right there, right? But to make this work out, if I'm going to let that be u, then I don't need, well, let's just follow along what I did. And then you'll see why, I hope. So if I take that x plus 5, and I rewrite that as x minus 3 plus 8, because negative 3 plus 8 is 5. Then I can divide it up, okay, into two separate fractions. So I can do the integral of x minus 3 over the denominator dx plus the integral of 8 over the denominator dx. Yeah, Alex?
If you separate it as x over the denominator plus y over the denominator.
And then mess around with it?
And factor y.
Well, if you do that, if you've just got x here and 5 here, are you sure you're going to be able to get it to work out with the du? I mean, maybe you can. What I think you'll have to do is add, well, if you just had the x, what I think you'd have to do is put in a negative 3 and then a plus 3 and then break that up, and you'd end up with 3 integrals instead of just the 2, I think is what would happen. All right? So once we've broken it up, then look what you can do. If you let u, now, did you see this coming? If you let u equal that whole quantity, then du works out because it's got the x minus 3 in the top. And on the other one, if you let u equal, well, v equal what you really probably thought you wanted u to equal to start with, the x minus 3, that works out. So stare at that one for a minute and see if you have any more questions. All right, 37 instead of 35. All right, we ready to move on? On 37, they tell us to find or evaluate the integral, and then they give us a hint, complete the square if necessary, which would make me think it's going to be necessary at least most of the time in this section. All right, so for 37, we've got the integral of x plus 2 over the square root of negative x squared minus 4x. And I don't know, maybe this is one of those times where I need to add something and subtract something from the numerator. I don't know. Let's see what happens if we let u equal the quantity that has the exponent on it. So let u equal negative x squared minus 4x. If we do that, du equals negative 2 minus 4x dx. And then if I factor a negative 2 out of that, well, lo and behold, that's what I have there, isn't it? An x plus 2 dx. Only thing I got to do is multiply both sides by negative 1/2, so there's not a negative 2 sitting in front of it anymore. So, you follow me down to there? All right, so let's make our substitution then. So that'd be the square root of. Then we let all of that equal u, so that's the square root of u. And then x plus 2 dx, right here on this line, gets replaced with negative 1/2 du. Can't leave that blank, so multiply it by 1. And we've made our substitution. Huh, they tricked us. I didn't need to complete the square. Did you try completing the square? And did it mess you up? They are cruel. So rewrite it, power rule it, put the x's back in. I sure thought we were going to need to complete the square. That really is kind of mean, isn't it? I'll start putting that on all the directions on quizzes and tests. Complete the square if necessary. All right, what else? 54. All right, on 54, let's see. Use the differential equation and the specified initial condition to find y. So in other words, solve the differential equation. Okay? So the differential equation they give us is dy dx equals they give us dy dx equals 1 over 4 plus, I've already got it written, over 4 plus x squared. And the initial condition they give us is that y of 2 equals pi. All right, so if dy dx equals 1 over 4 plus x squared, multiply both sides by dx, integrate both sides. The integral of dy is y. And then we would say that we have the integral of 1 over 4 plus x squared dx. Wow, that's an arctangent one. It doesn't even require us to mess around with it. All right, that's the integral of 1 over 2 squared plus x squared dx. So a equals 2. There isn't a u, it's just x. So we get 1 over a times the arctangent of u over a. So 1 over 2 times the arctangent of x over 2 plus c. So that's our general solution. Now, y of 2 equals pi means that when x equals 2, y equals pi. So when x equals 2, so put in a 2 right there for x, y equals pi. So put a pi right there for y. That gives us that, which gives us a way to solve for c. So we can get a specific solution or a particular solution instead of a general solution. Arctangent of 1 is pi over 4. So we get pi equals pi over 8 plus c. Subtract pi over 8. And 7 pi over 8 equals c. And that then is our particular solution. All right, anything else? 33. Right on 33, we're finding the integral. They tell us we may need to complete the square. And we don't right off the bat, at least not the way I worked it. And I really do mean at least not the way I worked it. There may be another way. There may be a better way. This is the way I worked it. All right, so if I let u equal the entire denominator, then du would be 2x plus 6, which is pretty cool, right? But I don't have a plus 6. But I will if I add 6 and subtract 6. Once I add 6 and subtract 6, then I can break this up into this integral plus, and then that's negative 6 over that, but I factored out the negative 6, put it in front, so minus 6 in front, integral of 1 over. All right, so I'm thinking we're going to complete the square. I'm really, really, really hopeful. So I'm leaving a blank there, scooting that 13 down. Okay? So, look, I'm in awesome shape up here. Because I can make the substitution, I can take that integral, I can put the x's back in. That really does have to kind of be easy at this point, doesn't it? Okay? Now let's concentrate on that second one, though. All right. If I'm going to try to make this an a squared plus u squared, it's not going to be an arcsine or an arcsecant because there's no square root in the denominator. Okay? So maybe it's going to be an arctangent. I'm going to try to make it one because I still want to complete the square, which the only reason I would do that is to make it an arctangent one. Okay? So if I do that, I need to add 9 and subtract 9 so that I have a perfect square trinomial there. So when I factor, and look, you got to keep up with the negative 6 in front, you got to keep up with the dx, you got to keep up with the integral sign, you can't let any of that go. But then the x squared plus 6x plus 9 can be factored because it's a perfect square trinomial to get a u squared, and then 13 minus 9 is a 4. That works pretty good as an a squared, doesn't it? So I don't need to use u because I did that in the integral in front, but you need to think of it as v equals x plus 3. Well, then dv would be, let's see, the derivative of x plus 3 would just be 1 dx. So I don't have to really mess with it. And I can do this part in my head. So keep your negative 6. The only thing I have to do is 1 over a, so 1 over 2, arctangent of u, in this case v over a, and since v was just an x plus 3, I went ahead and put it back in, plus c. Make sure you end with x's, not v's and not u's. All righty, I think that's where we'll stop. Oh, Kristen, one more, Kristen. 67. Oops. All right, on 67, what are we doing? All right, we're finding the area of the region. So the equation they give us is y equals 3 cosine of x over 1 plus sine squared of x. And then by inspecting the graph, I get the left end point of negative pi over 2 and the right end point of pi over 2. So the area is going to be the integral from negative pi over 2 to pi over 2 of 3 cosine of x over 1 plus sine squared of x dx. With me on getting the right definite integral? Okay. So if we let u equal the sine of x, we can actually turn this into an arctangent problem. Okay? If u equals the sine of x, the derivative of that is cosine of x dx, which is awesome, right? But we don't have a 3 in our du, and we need one. So instead of getting rid of a constant, we're putting in a factor of 3. So multiply both sides by 3. Don't forget, you got to change your limits of integration. So if x equals pi over 2, you would equal the sine of pi over 2, which is 1. If x equals negative pi over 2, u equals the sine of negative pi over 2, which is negative 1, which leads us to this. Can you follow me on the substitution? I'm substituting it into right here, except I've changed my limits of integration. So that becomes that one, that one. All right, then I'm substituting right there. Okay? Go with me? All right. So the integral, keep the 3 out in front. The integral of 1 over 1 plus u squared du is 1 over a, so 1 over 1 times the arctangent of u over 1, no plus c, evaluated from negative 1 to 1, and go from there.